Hi, I'm going to go over how to write up a subsystem, but using, if you have a PIC chip. So a subroutine is classed as a subsystem, okay? So obviously, same sort of thing for the design spec. What does it do? Obviously, if there's any timings or anything like that. I probably wouldn't really talk about power supply actually, so I'd be tempted to not use those two. But obviously, you can talk about what does it do. Um, you could say things like, has it got memory? Is it memory? Is it got to remember buttons? Are there going to be any input buttons or inputs to it? Is there going to be any outputs? Those sorts of things. Obviously, it doesn't really matter about parts list because it's just going to be a subroutine. So again, try and stick to 3, possibly 4 would be great. You can find alternatives though. So let's just look at this code here. So this one is a cat feeder. Okay, so I'll just explain very quickly what's going on with the cat feeder. So this first bit is the initialization. So it's basically going to be flashing until you press or port B, 1 is pressed. So it's going to stay in this routine till port B, 1 is pressed. Okay. Then when that happens, so you press that, you've got to then unpress the same button. So now the system is on. So those 2 lights will turn on. So now it's waiting for the cat sensor. So it's waiting for the cat to come close to feed. The cat sensor is attached to port B, 0. So you might be thinking, well, hang on a sec. My cat sensor would be an external sensor, so like a light sensor. That would class as a subsystem, your external light sensor. But you could also class this bit here as a subroutine. Okay. Then you've got a delay. The motor turns on for an amount of time. Then you've got some sort of memory as well. So you've got some idea of memory storage there, and then returning back. So you've kind of got 4 subsystems in here. There's definitely 4 subsystems. Okay. So I'll start us off. So, oh, where's that disappeared to? So I'm going to start us off of just this initialization bit. I'll take all of that, in fact. So this will be the initialization subroutine, or the which is going to cause the flashing thing. So let's go back to this circuit here. So where it says circuit diagram, that is where your code is going to go. Oh dear, it's gone a bit weird. Sometimes it goes a bit like that, so you might need to sort that out. In fact, what you could do, let's Control Z it. We'll go back to this. We'll go back to this code. What I'll do is, if I make it a bit bigger, options, right up there. If I make this a tiny bit bigger, is that the largest I can make it? Okay, that's fine. Okay, so if I make it a tiny bit bigger, then I can use snipping tool. Snipping tool. Take the bit I need, and then Control C to copy it, and then Control V to paste it. There you go. That looks lovely, doesn't it? So there you go. So that's the circuit diagram. So alternative. So basically, this is flashing. This is flashing. So an alternative, what would be it? Obviously, it would be an A stable. So you'd just go to Dan's circuits, go down to some sort of A stable. There you go. Let's snip this in. That would be your alternative subsystem. Obviously, Control C. Let's put that back into there. Alternative subsystems considered. There is your alternative subsystem considered. Then what you would do is you would write down, well, I've considered the A stable. You'd obviously attach that to the LED you want to flash. But obviously, because you're using the PIC chip and that can do that, that's why you'd consider, or that's why you didn't consider using an external A stable. So you could write down the reasons why. But that would be an alternative to this. Yeah. Okay, and then it says explanations. So what you might want to do is you might want to, in words, write down what's going on. So you can say, the first bit, you can label it. So you can say the first bit checks to see if port A0 has been pressed. If it has or hasn't, it should increment a register called store. You can say more on that later on. it then flashes port B, 6, so you'd observe the lights turning on and off. Then you'd have a very, very short delay with the no operations. Then it waits to see if port B1 has been pressed. If it has or hasn't been pressed, it will make a decision. So you're putting that into words. You're writing it in there. Okay, that's what you're going to do. Okay. Obviously, there'll be no calculations for that. Okay, but things like the delay subroutine, you might want to write down that it puts a specific number in, then it will count down to 0 or whatever it might be. It should take this many seconds. Yeah, so you can write that sort of thing. So this lot won't be in there, obviously. Okay, test procedures. So obviously, what you're going to do is you're going to open it up on the VPIC, and then you will test what's going on. You'll observe what's happening. So you should observe port B, 6 flashing until you press port B, 1, and then it should jump to the next part. Test results. Okay, so how would you get test results? How I would do it is I would do that. So you can see, oh, that shouldn't be pressed actually. Sorry about that. Let's do that to go back to the beginning. So you can see that that's flashing. But it's flashing so quickly you can't really see it. So why don't you pause it and get it? So step through the system until you can see the light turn on, which is there. Then what I would do is do a little screen grab. You can see the idea of what I'm showing here, can't you? There you go. Control C. Test results. We're going to put that down here. And then you're going to write down what's happening. You can see, as you can see, the instruction previously was bit set file port B, 6. That turns it on. And then the next instruction will obviously be clear, won't it? Let's step through. You can see it's cleared now. So then you can do a screen grab of that and say this shows that. Also, in that same subroutine, you've got to press the button, haven't you? Notice there it says bit test file skip if clear port B, 1. So let's press that, step through, and you can see on the next command it should now go to call ready because it has not skipped it. It should skip it if it's clear. It's not clear. So again, you might want to do a screen grab of that page as well. And you can see, as you can see, Control C, as you can see, it's done that as well. Paste that into there. So you've really comprehensively tested that subsystem. And then analysis of results in comparison with spec. Basically, copy and paste your spec, and then just write down whether it meets those spec points. So you can really see that you've got some decent testing. It might be, guys, that your test results, you might want to do it on the development board as well, which you can do. So feel free to use the development board, the PIC development board, and get some photos of it working. Yeah? And then sort of explain the photos, each test photo. So you'll do that times, obviously this lot isn't in there. You'll do that if there was 4 subroutines, you'll do that for all 4 subroutines, yeah? Obviously make sure you write an explanation of your alternative. So once you've got your PIC code working, it's not that difficult to get your 4 subsystems and write down. So I'm just going to show you the next one here. So this one here is waiting for the button to be pressed, isn't it? So again, your alternative subsystem might be a different sort of sensor. It might be because you're using those 2 LEDs to turn on, aren't you? So it could be some sort of audible display. So you could maybe have a transistor with a buzzer, and you could say instead of using the LEDs turn on, I'm using a buzzer turn on to show that the system is on. Obviously, the drawback of that is the buzzer would stay on. So you can find an alternative to that. This is a delay. You can find an alternative to a delay. It would be a monostable external circuit. And this bit is storing the answer, isn't it? So it's decreasing the number, and it's kind of storing something there. So you could use memory as an alternative. So you can find memory chip, or in the notes you've got a series of latches, I believe. Let's have a look. I think if you go up here, back up here, you've got an up counter, you've got a shift register. There you go. So that's 4 bits of memory, the 4-bit edge triggered latch. So that you could store numbers using that. Yeah. That would work as memory. So everything is there that you need. You've got alternatives. You should be able to write down what's going on. You should fully understand it. You should get some really decent testing. So as I say, most of the PIC ones, your subsystems, your subroutines will be subsystems. Your external ones will, your switches will not count as external on their own. The LEDs will not count as an external subsystem on their own. They will be within the subroutines. Things like if you use a 7-seg display, that would be an external one, that would be fine. Like I said before, if you use a sensor, like to sense the cat, that would be a subsystem as well. Okay, so just check. Yeah, just check what they've got. Feel free to ask us if you need to. Okay, I hope that's helped for you guys writing up your Section 2 subsystems. Obviously, make sure you really crack on with it because we want to be building in lesson, getting your circuit built and tested and that sort of thing for Section 3. Okay.